using Gauss's law, I am going to explain you to how to solve this problem. So this is NCERT example 1.11. So in this problem, they have given a cube of side length A. So this is placed at this point from the origin along the x-axis. This is given A. A is 0.1 meters. It's given 0.1 meters. Right. So now they are applying the electric field along x-axis. This is some constant times, some alpha times x power 1 by 2. Alpha value is given 800, and the electric field along y-axis and electric field along the z-axis is going to be 0. So which means there is no electric field along the x and y-axis. The only electric field along this direction is my Ex. But the electric field along x-axis is this variable one. So my x value gets increases, my electric field also gets increases, which means if I put x is equal to 0, electric field at point origin is also 0. If my x value gets increases, my electric field along x-axis also gets increases. So now I am going to consider in a cube we have a 6 faces, right? We have a 6 faces, but my electric flux through this cube only along 2 faces, because remaining 4 faces the electric field is 0. So my electric field only along this face as well as this face, right? So I am going to consider this face is called left face. Normal of the left face is my normal of the left face. So this is called the normal of the right face. So I am going to consider 2 faces since my electric field along y-axis and z-axis is 0. So only electric field along x-axis. So if I am supposed to consider this is my cube, so in this direction we have a normal. This is my normal of the left side. So this is my normal of the left face. This is the normal of the right face. So now my target is to find the electric flux through the cube and then the charge within the cube. First I will solve the first part, the electric flux through the cube. So what I am going to do here, I am going to find the total flux. To find the total flux, I am going to solve into 2 parts. One is your left face, second is for your right face. So I am going to split this here for a left face and right face. For left face, my electric field is a function of x. So from origin to this point is distance is going to be A. For left face, I can simply write my electric field at A. I can simply write EL equals to some alpha times A power 1 by 2. So instead of taking x, I am taking the distance from the origin to the left face is A power 1 by 2. Next I am going to write electric field for the right face. So E R equals to alpha times this is 1A, again this is another A. So I can simply write 2A power 1 by 2, right? So electric field along the left face, this electric field along my right face. So now what is my flux through the left face? So the flux through the left face I can simply write EL. So side length is L, up A has to be A square cos 180 degree. Sir, why cos 180? Because my electric field and the normal vector are anti-parallel each other. Then I am right, this is going to be minus EL A square. And then I can simply write for the electric flux for the right face, phi of R equals to ER A square cos 0 degree. Since my normal of the right face, which is parallel with the electric field along the x-axis, so I put cos 0, my flux through the right face I can simply write ER A square. So now my target is to find the total flux. So the total flux I may write phi equals to phi left plus phi right. to the flux through the left phase and the flux through the right phase. So if I substitute this value and this value here, I can simply write the equation here. A square is common here, so ER minus EL. So now I am going to substitute my EL value and ER value from here, then I can simply rewrite this equation as A square alpha times 2 alpha times root 2 a power 1 by 2. If I substitute my E of R here, I am getting something. Next I am going to substitute this value from here. It's going to be alpha times a power 1 by 2. So in this case alpha is common and a power 1 by 2 is common. So I can simply write alpha times a power, already a square is there, a power 1 by 2, a power 1 by 2 plus 2 plus 1 by 2, 5 by 2, a power 5 by 2 root 2 minus 1. So if I simplify this, I am getting the value alpha times a power 5 by 2 1.414 minus 1. So this is the net flux through the cube. Okay, so my alpha is 800, A is 0.1 meters. So this is also again is going to be a non-zero value. So my flux through this Gaussian surface or this cube is going to be a non-zero value. If my flux is a non-zero value, so there should be a charge inside the cube, right? Because if my charge inside the cube is 0, my total flux is also going to be 0. But in this case, my total flux is not going to be a 0. It's going to be a non-zero value. So I can simply write I can simply say there is a charge inside this cube. So my total flux I can find from this here. I just leave this as a next I am going to write about the expression for the second part, the charge within the cube. The charge within the cube. How can I write? Using the Gauss's law. So phi equals to q by epsilon naught. So I may write the flux value, the total flux from here. This is a non-zero value. If I substitute this flux value here, then I can simply write my q is equal to phi into epsilon naught. Just substitute this value here, then you are able to find the charge enclosed by the cube. So I just leave this calculation as a homework. So I just stop at this point. If you have any feedback, just write in the comments. So if you like this video, share it with your friends and subscribe our channel to get the regular updates. Thanks for watching. If you are not watching our practical videos, that's in the separate playlist in our channel, just go and watch it out. Thanks for watching. We'll meet in the next video.